Pripyat, Ukraine, once a thriving hub of activity, this city was home to nearly 50,000 people bustling with life and energy. Today it stands as a ghost town, frozen in time. The streets that once echoed with the laughter of children and the hum of daily life are now eerily silent. The abandoned buildings once filled with the hopes and dreams of its residents now stand as eerie monuments to a disaster that unfolded decades ago. Windows are shattered, doors hang ajar, and the interiors are left to decay. Over the years, nature has slowly begun to reclaim this deserted landscape. The once meticulously maintained parks and gardens have given way to wild overgrowth. Weeds push through cracks in the pavement and trees sprout from rooftops, creating a surreal blend of urban decay and natural rebirth. The relentless march of nature is evident everywhere you look, and in the shadow of the Chernobyl nuclear power plant, a curious phenomenon has emerged. Black frogs. This area, once teeming with human activity, now hosts a different kind of life. These are not a new species, but eastern tree frogs, which are normally a vibrant green. The intense radiation levels following the 1986 disaster have driven a visible evolutionary change. The radiation has caused these frogs to develop a darker pigmentation, a stark contrast to their usual bright green. This adaptation is believed to help them better survive in the irradiated environment. These black frogs are a stark reminder of the enduring impact of the disaster, but also a testament to the resilience of life itself. Despite the harsh conditions, life finds a way to adapt and thrive. The story of Pripyat and its black frogs is a poignant example of nature's ability to reclaim and transform even the most devastated landscapes. On April 26, 1986, a routine safety test at the Chernobyl nuclear power plant went catastrophically wrong. A flawed reactor design and human error combined to create an explosion that ripped through reactor number 4. The world watched in horror as a radioactive plume, unseen but deadly, drifted across Europe. In the immediate aftermath, 31 people lost their lives. Thousands more would later suffer from radiation-related illnesses. The Soviet government established a 30-kilometer exclusion zone around the plant, evacuating over 100,000 people from their homes. It was a stark admission. This land was now too dangerous for human habitation. Eastern tree frogs are normally a bright, leafy green. This vibrant color is not just for show. It serves a crucial purpose in their natural habitat. This camouflage helps them blend into their surroundings, hiding from predators and making it easier to ambush prey. The green hue allows them to virtually disappear among the leaves and foliage. But in Chernobyl, being green became a liability. The catastrophic explosion in 1986 changed everything, altering the environment in ways that were unimaginable. The explosion released melanin-altering radiation into the environment. This radiation had far-reaching effects, impacting not just humans but also the local wildlife. Melanin, the pigment responsible for skin and eye color, also plays a role in protecting cells from radiation damage. It acts as a natural shield, absorbing harmful UV rays and other forms of radiation. Frogs with higher levels of melanin and thus darker pigmentation were more likely to survive and reproduce in the contaminated environment. This darker pigmentation provided them with a better defense against the increased radiation levels. Over generations, this led to a noticeable shift. The once bright green eastern tree frogs began to evolve, their colors darkening as a direct response to the new environmental pressures. The exclusion zone now teems with eastern tree frogs that are black as coal. These black frogs are a stark contrast to their green ancestors, showcasing the power of natural selection. This rapid adaptation is a powerful example of natural selection in action. It highlights how species can quickly evolve to survive in drastically changed environments. The story of Chernobyl's frogs is a testament to the resilience of life, even in the face of extreme adversity. These black frogs are not just survivors, they are a symbol of nature's incredible ability to adapt and thrive. Their evolution is a reminder of the ongoing impact of the Chernobyl disaster and the remarkable ways in which life continues to find a way. As we look at the thriving wildlife in the Chernobyl exclusion zone today, we are reminded of the complex interplay between nature and the environment. The black eastern tree frogs are just one of many examples of how life can adapt to even the most challenging conditions. The story of Chernobyl's frogs is a fascinating chapter in the broader narrative of evolution and adaptation. It serves as a powerful illustration of how species can change and evolve in response to environmental pressures, ensuring their survival for generations to come. The Chernobyl exclusion zone, despite its tragic past, has become an unexpected natural experiment. With human activity largely absent, wildlife has flourished. Wolves, lynx, and wild boar roam the forests, birds of prey nest in abandoned buildings, and scientists have documented numerous examples of adaptation to the radioactive environment. Plants have developed mechanisms to repair DNA damage caused by radiation. Insects display altered coloration and behavior. The exclusion zone is a stark reminder of the destructive power of radiation, but also a testament to the incredible resilience of life on Earth. Section 5. Can humans adapt? The science of radiation resistance. The black frogs of Chernobyl raise a tantalizing question. Could humans ever adapt to live in heavily irradiated environments? The answer is complex and multifaceted. These frogs have developed a darker pigmentation, which scientists believe helps them absorb less radiation. This adaptation is a fascinating example of how life can find a way to survive even in the most hostile conditions. Humans, like all living organisms, possess some natural defenses against radiation. Our bodies have evolved mechanisms to repair DNA damage and protect cells from radiation-induced harm. However, these defenses are limited and can be overwhelmed by high levels of radiation. Melanin, for example, offers a degree of protection. This pigment found in our skin can absorb and dissipate some of the harmful radiation. But melanin alone is not enough to protect us from the intense radiation levels found in places like Chernobyl. Scientists are studying the genetic makeup of the Chernobyl frogs as well as other organisms thriving in the zone. They are particularly interested in understanding how these creatures have adapted to such extreme conditions. By examining their DNA, researchers hope to uncover the secrets of their radiation resistance. They're searching for specific genes that confer radiation resistance. Identifying these genes could provide valuable insights into how we might enhance our own defenses against radiation. This research is still in its early stages, but the potential implications are enormous. The hope is that this knowledge could one day lead to medical breakthroughs, such as new treatments for cancer patients undergoing radiation therapy. By harnessing the power of these genetic adaptations, we could develop more effective ways to protect and heal our bodies from the damaging effects of radiation. This could revolutionize not only cancer treatment, but also our ability to explore and inhabit environments with high radiation levels, such as space or nuclear disaster zones. Section 6. The ethics of return. Reclaiming a contaminated land. The idea of humans returning to live permanently in Chernobyl raises complex ethical and environmental questions. While some areas within the exclusion zone are now considered relatively safe, others remain heavily contaminated. The long-term effects of low-dose radiation exposure are still poorly understood. Furthermore, the exclusion zone has become a refuge for wildlife. Repopulating the area would inevitably disrupt this fragile ecosystem. The decision of whether or not to allow people to return to Chernobyl is not simply a scientific one. It is a moral dilemma with far-reaching consequences. Section 7. Lessons from Chernobyl. Understanding our impact. The Chernobyl disaster serves as a stark reminder of the devastating consequences of nuclear accidents. It highlights the importance of nuclear safety and the need for responsible stewardship of this powerful technology. But Chernobyl also offers valuable lessons about the resilience of nature. The abandoned landscape, now a haven for wildlife, demonstrates the remarkable ability of ecosystems to recover, even from catastrophic events. The black frogs, a symbol of adaptation, remind us that life finds a way, even in the most challenging of circumstances. Section 8. The future of the exclusion zone, sanctuary or science lab. The future of the Chernobyl exclusion zone remains uncertain. Some advocate for its continued preservation as a nature reserve, a living laboratory for studying the long-term effects of radiation and the resilience of ecosystems. Others believe that certain areas could be safely decontaminated and repurposed, perhaps for agriculture or renewable energy production. The challenge lies in balancing the potential benefits of human re-engagement with the risks of further environmental damage and the ethical considerations of disturbing a site of such profound historical and ecological significance. Section 9. The Black Frogs of Chernobyl. A symbol of hope, the black frogs of Chernobyl, once a symbol of disaster, now represent something more profound. They are a testament to the adaptability of life and the enduring power of nature. Their existence offers a glimmer of hope in the face of environmental adversity. As we grapple with the ongoing challenges of climate change and pollution, the black frogs of Chernobyl remind us that even in the darkest of times, life finds a way to adapt, to persevere, and ultimately to thrive.